Hello, this is Mark Atwood with the OpenShift team at Red Hat, coming to you from the MySQL conference in Santa Clara. And today I'm going to show you about the OpenShift Do-It-Yourself language module. OpenShift supports several well-known language environments, including Java, Ruby, Node.js, Python, PHP, Perl. But suppose you have some other language, like an application framework written in Smalltalk, or a business application written in COBOL, or a numerics application written in Fortran. If your application will run on Red Hat Enterprise Linux, it will run on OpenShift. Let me show you how. I'm here at the OpenShift console at openshift.redhat.com, and I'll use the console to create an application. If I go to Manage Your Apps, I will see a list of all the applications I have currently running. And if I select Create a New Application, I'll see a list of all of the language runtimes that OpenShift currently supports. Here's the Do-It-Yourself. It says the Do-It-Yourself application type is a blank slate for trying unsupported languages, frameworks, and middleware on OpenShift. Please see the community site for examples of bringing your favorite framework to OpenShift. I'll select this application type to create one. Now the console is asking me for a name. I will call this application DIY and select Create Application. And here is my application having been created. The console shows me the URL my application can be reached at, and also the git clone command to pull the application down. I'll select that right now and run it. Git commands are run from a shell prompt, so I'll switch over to a shell to run it. Here's my shell, and there's the command, git clone, and then the git URL of an SSH type that will pull down the application from the OpenShift servers to my local desktop. You can see it cloning to Git, and then it pulls it down. Let's take a look inside. Emacs DIY. You can see a README that documents how the application is laid out. A DIY directory where my application is supposed to go, and then the very important .OpenShift directory, which contains metadata for OpenShift applications. For DIY applications, the most important place are the action hooks. Action hooks are shell scripts that fire at key points in the life cycle of the application. All OpenShift applications have build, deploy, post-deploy, and pre-build hooks. DIY also adds start and stop. Start and stop scripts are run when the application is supposed to be started or stopped. And that's what I will fill in to start the application as I write it. I happen to have a do-it-yourself example application sitting in GitHub, so that's the one we will use. So let me switch over to the browser and we will look into GitHub. OpenShift keeps a lot of quick starts and examples in GitHub at github.com/OpenShift. Do feel free to go there and look around and find out what we have. The OpenShift Do-It-Yourself bin hello demo is what we're going to use. I'll grab the Git URL so we can clone it locally and look at it. So I copy it here. Let me switch back to my shell and make a git clone. Git clone and then the URL. And now I have an OpenShift Do-It-Yourself bin hello demo directory. Let's go into that directory and take a look around. I see start and stop, binhello.c, and binhello. Let's take a look first at binhello.c. Hello.c was originally an example program that came with MicroHTTP. MicroHTTP is an open source framework that lets you build a web server into any C program. As we page down through it, it's perfectly ordinary C code. You can see here the reference to the OpenShift internal IP and OpenShift internal port. This is information that OpenShift gives do-it-yourself applications to let them know how to link up. This is perfectly ordinary BSD socket code programming. You see the SYN family and the SYN port, the iNet P to N. Here's the start daemon, which is part of the micro-HTTP framework. It will just loop forever until killed. Now I could compile this program, but I have also in this quick start created a pre-built binary that does exactly the same thing. The key thing to remember is the application has to be able to run under Red Hat Enterprise Linux. So you should compile it under a Fedora or a CentOS or on a Red Hat Enterprise Linux machine. Now let's take a look at the start and stop scripts. The start script is an ordinary daemon start. We say no hup, bin hello, and then we redirect the output to the OpenShift log directory. The stop script finds the bin hello program in the process list and then sends the kill command. This is all perfectly ordinary Unix shell scripting. Let's plug these into our application. So I will copy bin hello into my do-it-yourself application, and also the start and stop scripts. Remember, it goes in the .OpenShift action hooks directory. Now let's jump over there and make sure everything's in the right place. Now let's go back down into our DIY directory. cd DIY. There's the bin hello and the rest of the files. I don't actually want bin hello to be in the root of the application. I want a bin directory for it. So I say make dir bin and move bin hello into it. Now let's look in the OpenShift directory. There in the action hooks. Let's look at the start. There's our start script. Let's look at the stop. There's our stop script. Notice again that the start script redirects standard out and stand error to binhello.log in the OpenShift log dir directory. Doing it this way means that any output the application generates will go to the logging directory and will be accessible to the OpenShift logging handlers. Let's go back up again. Now we've added these files, but we need to check them into Git. If I say git status, I can see the modified files and also the untracked and added files. So I will say git add bin and OpenShift. Say git status again. Here's our modified file and our new file. Git commit add bin hello and scripts. And now when I say git push, Git will push it back up to where it came from. In this case, the OpenShift servers. Okay, let's actually push it. Git push is the command. And here it runs. It sends the application up, it stops it, it restarts it. Now let's actually take a look at our application. If I switch back to the management console, I can see here is the URL for my application. Let's click on it and see what we see. Hello world. Let's take a look back at our source and see why it's doing that. If we look at our sources, what our application is supposed to do is send the HTML body hello world, which is exactly what it's doing. That's all there is to it. I have here a C binary application running on OpenShift using OpenShift's logging, OpenShift's get system to handle restores, and also it can handle OpenShift's snapshot and auto scaling. So, hello world, and world, please let us know what you're using the do-it-yourself application framework for. Again, if you have some crazy language or an odd binary or a framework that we do not yet support, the do-it-yourself application will probably do it for you. Thank you very much. Again, I'm Mark Atwood from OpenShift at Red Hat.